Aloha everybody, this is Gigi from Kauai Community College. This is a video on implicit differentiation. If you are in my class, this is number 9 in the practice handout. So question is asking for dy dx when sine of x times y is equal to x plus y. Okay, so you see here that y is not written explicitly in terms of x only. So we have to use what we call implicit differentiation. So we will go and take the derivative of both sides with respect to x. Okay, so in order to take the derivative of both sides with respect to x, on the left-hand side, the derivative of sine is cosine of what? Of whatever it is inside, multiplied by the inside derivative, which in this case would be a product rule. And the product rule applies with implicit differentiation on y. So derivative of the first, which is 1, multiplied by the second, which is y, plus the derivative of the second, which is dy dx, multiplied by the first, which is x. Okay, so that's the product rule there for the inside derivative on the left-hand side. On the right-hand side, the derivative of x with respect to x is 1, and then the derivative of y with respect to x is dy dx. So we are looking for dy dx, so we have to go and solve for dy dx. So now that's just algebra, right? So isolating dy dx. It is inside this parentheses here. So in order to solve, we first need to distribute. So when we distribute, we will have y multiplied by cosine of xy plus x cosine of xy dy dx is equal to 1 plus dy dx. Okay, so to solve for dy dx, we would have to get everything with dy dx on one side. So I think I'm going to keep that on the right-hand side. And I am going to go ahead and subtract this term over there. Okay, and together with dy dx term here, I am going to factor out dy dx. So that will be 1 minus x cosine of xy when I factor. And then on the left-hand side, I will have y cosine of xy minus 1. So to solve for dy dx, we would divide by the factor that is attached right there. So dy dx will equal to y cosine of xy minus 1 divided by 1 minus x cosine of xy. And that is it.